I hope you had a refreshing break. And for our next session, I'm thrilled to introduce Kartikey Pant, Senior Technical Expert at Salesforce, who will present From Logs to Logic, a structured event system for Flink observability and AIOps. Thanks.
Thanks a lot. Good evening, and my name is Kartikey Pant. I'm from Salesforce. Thank you all for being here. Today we're going to go on a journey from unstructured, messy logs to structured, actionable logic. So this talk is currently about a structured event system, which I have proposed in the Flink community, and it's a flip. But like it's there for your suggestions and future things. So the Flink observability gap. Like Flink is an amazing system, but the automations that we have built on logs and the and metrics, they seem to have a gap. So essentially, any automation that is built in logs, using logs, has issues with changes in versions, because when you change versions, there's no strict pattern of the event log. The metrics just show us the what, not the why. They just show us the tip of the iceberg, not the root cause of why that particular checkpoint has been degraded or not. They have less structured and contextual information. And we are stuck in a cliff where AIOps needs a language, needs a structured, specific language, and not just data coming out from metrics, which shows us the what. Now, the proposed solution that we're going to talk about is an events reporter system. But before we talk about the system, I would like to share 4 guiding principles that should be there in any reporter system for observability for Flink. Firstly, stability first always. Like whatever we do with the observability, we should strictly not put the Flink core operations at risk, which means the job master taking checkpoints and managing the state and all of those stuff. But also provide immediate value. So the events that we are choosing or the reporters that we're choosing, they should have a real solutions for the problems that most of us are facing. The third one is extensible by design. It shouldn't be like a single, we create it first up and then we are unable to extend it via reporter, so it's very hard to add events for the same. And fourth one is built for the community. It should empower the ecosystem. It should be the foundation for something bigger that helps the community solve the AIOps problem. So on a high level, what we are proposing is a Flink Events Reporter System. So we have a Flink core component, such as a job master or the checkpoint coordinator, which generates a structured event, which is nothing but an operational signal. This structured event is then sent to a pluggable events reporter system. This decoupling is there to ensure the stability of the Flink job. And this particular events reporter then emits the structured data over to the right to external customers, which can be observability platforms, they can be specialized tuning tools, or AI/ML-driven analytical tools. So these external customers or the consumers may also include the operator itself, because it can use these contextually rich events in order to improve its own reconciliation and like more kind of, we can add tuning as well into that. Now, going a little deeper into the proposed events system which I talked about, which was essentially this, how is this event sent to the pluggable events reporter system, and how do we ensure the decoupling? We talk about this deep dive architecture of the asynchronous boundary. So the Flink's core component, which is, for example, we can take the job master, it creates a non-blocking offer, which doesn't block the operational flow of the job master itself, which is passed into an asynchronous boundary which is the core of the event reporter system. So this event gateway, which takes the event from the Flink core component, it adds this event into an array blocking queue, which uh, which is again a blocking queue. So essentially, it can either pass it to the event reporter if the event reporter is fast enough, but if the event reporter is itself lagging heavily, then we can use the dropping mechanism and just drop the queue when it is full. We just increment the counter metric for more observability on this particular queue. And so you must be wondering that we're dropping events as well, but that is in order to ensure the stability, because whatever we're doing to enhance the stability of the job master or the checkpoint coordinator. So we want our event reporters to be as fast as possible such that the 3B state never reaches. And it's a tunable events reporter system as well. So you can tune when you drop it, you can increase the size of the queue such that you never drop it. But just in case the event reporter is blocked, let's say the Kafka, there is some issue with Kafka itself, your connectivity with Kafka, then we can drop it out. So, but why this approach? We could be using metrics, we could be using log scraping, we could have a synchronous architecture which does not drop anything. So why are we going in the async events way is the general question which may come. So as I talked earlier, briefly, like if we use log scraping, like many of us use log scraping for building automations because we already have our logs which are being emitted by the application. You can just parse them and create an automation which does certain things, gives you certain insights, etc. But the thing is, like, it can break your application. Let's say you go from Flink 1.2 to Flink 2.0. There will be no event schema or no specific schema which would be published. So the log itself can change along with minor versions as well. So you'll have to keep track as an application owner of all the versions and their logging in order for your application to be functioning correctly. Hence, log scraping is a little fragile path which all of us currently follow. The second way is the metrics way. So the operator currently already uses metrics for certain auto-tuning and like scaling tasks. So even though it gives you a potential for reactive scaling and perhaps potentially proactive as well, but you still can improve your proactive scaling by a margin if you have the feature of exporting, let's say, the whole SQL query execution graph, plug it in as an event into the AI/ML tuning framework. And or let's say you have a job snapshot, a job graph execution as well. That also you can plug it into the events AI/ML reporter system. The third way is the synchronous way, which I already talked about, that it may block the Flink score component itself. That's why we are not going that way as of now, but I'm happy for suggestions and in the Flink dev list, which I'll share later. So how will an event look like? So this is just a V1 of what I have proposed, and it's not a set in stone kind of a thing. We are still, it's up for suggestions. So like every event has a header and a payload. Header contains metadata or other stuff like, let's say, event type itself. And the payload has all the performance metrics kind of things, which help you give a richer view of the event itself. So you can use something like a job ID and an execution attempt ID to trace the exact jobs history across multiple restarts. Because if you have a track of the execution attempt ID itself, then you're able to set a story around it. On the other hand, even the first thing which the event parser can do eventually is to see what event it was. So if you have a log, you have to parse the log in order to know whether it's a useful log or not. But here, it's a simple JSON or another kind of serialized structure, and the first key that you may check for is the event type itself, which is, let's say, in this case, checkpoint completed. And you have a payload which contains precise performance data, which helps you monitor the job more deeply. So how do we do it though? Like as an application owner, like you just have to use a little something what you already use for a metrics reporter. So like in a metrics reporter, you can set metrics.reporter.class, stuff like that. You can configure, like for example, for this one, because events itself is an overloaded term, I have created this observability.events namespace in the Flink conf itself. So you just specify these set of things or even more things which will come up under the observability.events namespace. And these would enable the application owner to get these kind of events, which is just a visualization of things which have all sorts of information that the user needs. And eventually, we can add more kind of events and more kind of reporters as well, so that you can extract these events into whatever kind of data storage that you want. So right now, I am giving, I'm going to play a demo where we'll just see that, okay, once you have this events reporter system, then what all things could you build around it? It's playing, right? Yeah, let's say you have a Flink cluster like this one. The user specifies these settings into the Flink conf, observability.events namespace. They can set the reporter class to be file events reporter or Kafka events reporter eventually when it comes, and then you can plug it into Druid or some kind of events viewer and query system. Then you have something called path, which is relevant for the file event system. You can set the events that you want to filter upon. For instance, here we have job status changed, checkpoint completed event, checkpoint failed event. And these are the three parameters we have for stability right now. We run a job. In this job, we have a demo event generator kind of a thing. And I've created a Flink events dashboard to visualize the events real time. So like people can parse the key value pair and parse only those keys which they really need. They can set up baselines, not just out of numeric values, but also specific contextual information, which we can add. They can use these job IDs, timestamps, create new fields like efficiency, which is nothing but the time divided by the duration. And they can analyze patterns such as accelerating degradation across multiple execution attempts as well, since we have a track of the execution attempt as well. You can analyze anomalies. You can highlight specific things into the events and parse them as you need. You can also have different kinds of visualizations to see so which are common in events workspace. You can quantify certain things as well using the performance metrics which are coming as inbuilt inside the event payload. But you can, but it's more contextual in the sense that it helps you track a lot of information, not just the successfully completed ones, but also the failed ones. You can have failure reasons embedded inside the event as well. So it's essentially like you're clubbing metrics and logs together in a more structured way to analyze and get insights about things in order to make it a uniform language for AIOps itself. Uh, yeah. So, so these are a few events and just a timeline of it. Yeah. So this was basically what could happen eventually once we have the event reporter framework. For this one, I have created an event gateway. I have already implemented it, but I'd like suggestions on the same and how to make it better and more inclusive and more stable and reliable. I have created a Flink discussion as well in the dev at Flink channel. So yeah, so this is an invitation to collaborate. So like we have a lot of things eventually we can do with this. This flip is about setting up a foundation for more future reporter systems like the Kafka reporter system, like the like Open Telemetry reporter system as well. Because if you have structured events coming out of the core components of Flink, that will give us much more details on how to make our Apache Flink systems better. Apart from that, like another future event which we are keenly looking forward to is the job graph snapshot event, which essentially helps you extract the job graph into an external application for further analysis. Because sometimes it happens that we have all the metrics, we have all the like logs as well, but we don't have the exact job graph which was run for that particular thing and what happened inside Flink itself. So I'd like for all of you to review the proposal document. I have attached it in the QR code, and it's also in the dev at Flink .apache.org, and join a discussion over there because that's the right way to do it. And thanks a lot. I'll be happy to take the questions if there are any.